Seems good enough. Okay, so now it's time to actually go and do something. Alright, so first of all, I'm sorry, I'm a bit ill today, so I'm just gonna sip a lot of tea, and so I might cough, so yeah. Second, I fixed my DVI, sort of fixed it, because actually I wasn't able to find the root cause why the after a certain uses commit it stopped working. But when I do the minimal differential pairs, nothing it is the same between versions, but if I make a uh, somewhat complicated design, it has a difference. But at my current level, I'm just not able to actually go through and debug this stuff, because it's just the diff is very big and it's complicated, so I don't know what to do. So I just changed it to the vendor specific primitive that works. And also I have a new combinational asynchronous RTL generic solution that also works, but it gave some warnings on PNR stage, so I decided that actually if I want to make it good, I have to just use the LVDS primitive to output the differential signals. So I'm using this. I can even show you though. So for example, we can go to the OpenDVI. Is it the right version? Yes, it is. So if we go to RTL in DS buffer, now we have, if we are using Govin board, then we're gonna just instantiate Govin primitive, right? And if we are not using Govin board, then we're gonna go straight ahead and use generic solution that is just an always comp that outputs differential signals. Right, so the plan for today would be actually to change the old project of mine, sort of add a new board, which is Govin Primer 20K, and also my where is it? It is yeah. So I've done this project a little bit more than a year ago, and what I wanna add now, well, first of all, it used an Altera Cyclone 4 chip, and it had a how can I say, VGA output, right? VGA output. And what I have now is I have this board. You can't see it really well, but yeah, maybe I can just unplug it and show you properly. So this is Tank Primer 20K, right? Oh, give me a sec. Yeah. So this is Tank Primer 20K, and it has HDMI output. Like, I'm not using the actual full HDMI spec, I'm just using it as a DVI. But nonetheless, I have to do two things. I have to write the proper wrapper to make this Pong game work on this new board. So I have to instantiate the PLL for the board, and I guess basically that's all. Actually, I don't think I have PLL there. Probably nothing. I just have to assign the right pins, and we'll be good. Yeah, but I still need PLL for the DVI, right? So basically the plan for today would be to make this old game of mine work on a new board, right? And yeah, and also we will use the open source toolchain for all this stuff. So we're gonna use Yosys. This is the open source synthesizers, if someone's not familiar with it. Yeah, we're gonna use Yosys, and yeah, and actually this project has a lot of sort of complicated SystemVerilog. Maybe I'm gonna show it in the probably game top would be a good module. Right, so I'm using packages everywhere for my parameters, and I'm also using interfaces. And a lot of SystemVerilog synthesis tools has a problem with parsing this stuff, or the functionality is incomplete. So we're gonna see how it works, because right now I don't only have the excuse me, I don't only have the an interface. I have an array of interfaces, right? So yeah, this might be problematic, but we'll see how it goes. Um, yep, I think there's not much to share than this. We'll just yeah, we'll just go ahead and see how it goes. And also, I'm kind of curious what kind of frequency we'll get with this setup on the new board, because it has a kind of advanced node. I think on the Altera I had around 100 megahertz, maybe like 80, 90, something like this. And I think we should have a much better frequency on this board, because this chip is just more modern. It has a more advanced node, right? Yeah, and we'll have to change the VGA driver for the new HDMI one. And let's see real quick what kind of interface do we have here. Right, so we have clock, reset, blah blah blah. Yeah, basically all it does, it provides coordinates, sync, and visible range. But do we actually need visible range in this implementation? I don't think so, because it was needed for the VGA, because as far as I know, you're not allowed to output any colors when you're in the blanking zone. So if the coordinate is out of the visible screen, all RGB signals has to be 0, right? But HDMI doesn't care about it. DVI doesn't care about it. It's gonna handle it on its own on the TMDS encoder side, so it's not needed. So I can probably, well, I can't actually I can't remove this, because I still want to maintain the compatibility with the VGA and Altera board. So I'll have to like tie it to, yeah. Basically, DVI also generates visible range, so I can use it. I can maybe make a separate signal to tie it, or I can just tie it to one. Doesn't matter. Okay, so basically we'll see how it goes. Yeah, and honestly, this VGA driver is flawed, because yeah, this is not correct, because right here I am forming the output based on the, or wait a second, is it actually done properly? H-sync, V-sync, coordinates. Yep, I think this implementation actually is decent. Or is it? Yeah, seems like it is. This is kind of interesting. Why would I have a... Oh, okay. So this is actually a working one, because it still outputs coordinates even if they are out of the screen, and mine just wraps it. So yeah, mine has maybe redundant logic, but anyway, I wrote it this way a long time ago, so uh I don't regret this decision that much, to be honest. Okay, so we have all this. So let me just grab the code real quick. Yeah, let's SSH. Um, yeah. So basically, let's git clone this, And so let me connect the board back to the HDMI and power slash USB for uploading the bitstream configuration. Yeah, as you can see, there's an image. You can see it really well from my mic, but yeah, so the DVI is working, and so the next step would be to just connect, like glue these two projects together. So let's see how it goes. Actually, oh, I don't have the Altera board with me right now, so I can't test if it breaks something, but I'm just gonna make a wrapper and hope that it's not gonna break too much, because okay, so I have RTL here, I have board stop that is actually um this is actually Altera board top, so maybe I should um I should rename it, right? From board top to the Altera board top. And let's see what the board package actually does. It has keys. Okay, so first of all, what I'm gonna do is I'm gonna rename it from board top to Ziova, which is actually the name of the board. I have to actually press enter. Yeah, so Ziova would be the configure the top module for the old board, and uh, and yeah, and configuration here would be um I can actually use parameter to generate the needed module. That would be cool. I'm gonna do this. So here am I gonna first of all, yeah, I have to like rename it to 01 board package, and yeah, I'll have to add 0 here as well. So let me just copy this here, and yeah, 0 will also go here. Okay, and next thing that I want to add here is I want to specify that display type maybe display type would be VGA for this. Should I just make it integer, because I think integer is always better. Yeah, so let's say that display type 0 means VGA and display type 1 means DVI. So I think it would make some sense, right? And I'm gonna add a comment that can I actually just use this? Yeah. 0 VGA, 1 DVI, HDMI, if someone doesn't know that it's the same interface here. Okay, so I think this is good enough, and I'll have to change the do I have like, yeah, I have quarters here. Yikes. Quarters. uh let's see, I don't even remember what kind of files there are. So yeah, set location pin blah 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 blah. All right, so it has like, it has different outputs. Oh, I don't mind. It doesn't matter because I'm just gonna use different wrappers. Okay, so this would work if I specified. Yeah, let's find like board package. Yeah, everything that's related to board has to change. It has to be changed to Ziova. Here as well. And I think it's like, yeah, Ziova board top. Yeah, I think this would do the trick. And about SDC, yeah, this is like irrelevant. I'm gonna use this. Okay. Maybe I should make a separate speed configurations, or I can just say that I can use the same clock on both boards. But yeah, I guess I don't want to fiddle with the timings, speed timings on both boards, so I'm just gonna instantiate PLL and do 50 megahertz on the 10 primer board. It has a board clock of 27, but I'm just gonna use 50, so I wouldn't have to change any timings, because it actually took me quite a while to get the timing correct, right? Okay, so as you can see, I won't have to change anything for quarters, or I think I wouldn't be able to test it right now, but let's pretend that it's working, because I don't have a board and I don't have the software. So let's go straight into the Verilog. Let's create a new primer 20k here. Yeah, so it will be a primer 20k board top. Right. Okay. And TB, yeah, we'll have to change it to primer as well. Primer 20k. Yeah, readme license doesn't matter. RTL. Yeah, let's go straight into RTL. So we have board top, right? And I have to change it to ZOVA board. Yeah, well, ZOVA board package, right? Because I have ZOVA. Wait, what? Oh, I have to actually, yeah, I have to go to include, and I have to rename it to ZOVA. Well, so this is ZOVA board package. Yeah, VGA, sprite, score, LFSR are all right, and probably it would be a good idea to create a separate directory for the DVI, because it has a bunch of files. So let's go straight and create DVI here. I'm gonna fill it later. Now let's create. Wait, do I still have board top for some reason? Oh, because I haven't renamed it as well. So board top is actually ZOVA board top SV, right? And let's create primer 20k board top SV. And let's go into the ZOVA. Let's copy everything to begin with. Cannot find an include file. Wait, what? It should find it. Wait, ZOVA word package SVH. It should find it, but okay, it's kind of irrelevant at this point, because what we actually and we have to change it to ZOVA board package here as well. Yeah. So I think we are done with ZOVA at this point. We should go to the primer 20k. So yeah, let's rename it to primer 20k board top. Let's name it to primer 20k board package. Here as well, primer 20k board package. Okay, so we have a package. It doesn't exist yet, so it's fine. Module here is correct. Clock reset keys, LEDs. Yeah, I'm gonna change these signals here a bit later, and I'm not sure I have to change any of this logic. Actually, let's open the oh whoa, it's here. Okay, so let's go quick to the OpenDVI and see how I've done the wrapper here. So do I need to change everything? Yeah, I have to invert reset, but other than that, probably the button has to be inverted too, though. I don't remember. Let's double check. Let's go to Git and let's open Govin OSS, and uh, right here I might have a something that works. So yeah, I invert reset, I invert all buttons, switches, and I invert what about LEDs? Okay, so LEDs are inverted as well. Huh. Interesting. Okay. So I'll basically have to invert everything, and let's go to the pin CST to get the right values for this. Okay, so how many LEDs would be necessary though? I wonder. Here I have like let's open package, zero board package. So I have 3 keys. I can't remember like what's the purpose of the number 3. Oh, like one key is up in Pong game, and one key is down. And what about the third one? This is interesting. Never mind. I think we'll figure it out. Okay, so RGB width is not needed, and yeah, LEDs W is 2. Okay, so we have at least 2 LEDs. Well, at least 3. Let's check where the LEDs are used. Let's open and go to like LEDs. LEDs here, LEDs here, LEDs, LED. Output assign LEDs. Okay, so they basically mimic the keys. So, yep. Yep is 1. Oh, I see. So we have 2 keys. So we need 2 bits to represent the each key. And we have 2 LEDs also to represent the state of these keys. All right. So nothing really tricky here. Okay, so let's let's try to implement this now. Okay, so first of all, this is pretty clever reset logic here. So I said that reset is 0 when you upload this bit stream, but after 1 clock cycle, it gets it sets to 1. Maybe I should add like more clock cycles, and maybe I should use a counter, but I think it's gonna work for now, and so yeah, I wouldn't mind for now. Okay, so probably what would be a better idea is to separate game top from the specific display driver, but I actually don't mind. Actually, it's solvable. Let's open game top. So it has game logic and it has game display. Okay, so now this is indeed kinda kinda weird. Let's open game display. What's in game display? So the purpose of this module is to output FPGA signals, new frame call, and what about these guys? That's like sprite display. Okay, so what's the point of this? It's like Oh, it is inputs. Okay, makes sense. So you provide the sprites, and display does the rest. But I'm not sure if I want to do it here. And yeah, a new frame is also generated here. I'll have to think for a second. How would I approach this? Probably I should create a separate interface that handles all the display signals, and it drags it to the um, top level, and on the top level we instantiate the right logic. I'm not even sure about this right now, so let me check actually what what VGA does here, what that is so important. Yeah, I probably should have made it more portable because I assume that everyone's gonna use VGA. Okay. Like okay, position. It won't go anywhere though. Yeah, it just uses for here. Usable range, blah blah blah. And the only thing that we output is the new frame. Okay, so I think we should be able to instantiate DVI here, and so we're gonna change this bunch of signals for the interface, and I think we won't have any issues with that. Okay, so this should be possible. Game display. Weird, but okay, whatever. You're gonna figure it out. So let's start from the most basic part. We're gonna create the primer 20k words package. Oh my, package svh. And so let's see what ZOR has. Let's copy everything. We're just gonna change, maybe I can just like go and substitute for everything 0, 1. Gonna change to primer 20k. Good. And I'm gonna change the stance as 0, 1 to primer 20k. Good. So we have everything here. What key is this? Probably reset this key also. Okay, makes sense. So we have 3 keys, 2 LEDs, and display type would be 1. And I don't think we need any more of the configuration. Alright. Okay, so this is good enough. And so what I will do is yeah, and creating an interface on the top level would be a bad idea, so I'm gonna drag display interface till the board top, and on the board level I'm just gonna assign it to a separate signal, so there wouldn't be any issues with the tool chain. Okay, so I think this would be sufficient for the board configuration. The rest would be handled by the separate DVI packages, right? Okay. So now let's populate DVI directory. So what I'll have to grab from here is I would need DS buff, I would need DVI sync, DVI top, serializer and encoder, basically everything but image gen and board top. Okay, so let's copy ds buff, dvi sync, dvi top, serializer, tmds encoder, and I'll have to copy it to git FPGA. Wait, what's the name? Pong FPGA, RTL, I said RTL, DVI, right? Yeah. Okay, so everything is here. We have everything that is necessary to handle DVI. Let's see what DVI top is about. It is okay, so oh, and I forgot to copy the package, but it doesn't matter. Yeah, so everything that is needed is here, and let's copy the package real quick. So let's go to include and let's just copy DVI package to the same stuff. This git pong RTL include. Yeah. So all the maybe I shouldn't even create the separate directory for the DVI and let it be here, but I think it would make sense to make DVI here. Yeah, to logically group everything. Okay, so we have include and we have DVI package here. And if I open DVI top now, I shouldn't have any problems. I still can find it. Oh, actually, I understand why. It's because I don't have anything related to DVI top in my primer 20 keyboard top. Okay, so let's do it right now. Probably what would be cool to do is really, first of all, what I see here is that there's just too much of this. So 6, this is good. Okay. So I have CLK, I have resets, I have keys, I have LEDs, and I'm gonna change this to the appropriate. Let's open DVI top. Yeah, so I can even just copy this, right? Yes, this is the appropriate. This is the appropriate signals for the DVI. Next thing that I'll have to do is I'm gonna create the pins, pin constraints. So I have to map the these RTL signals to the physical pins of the FPGA board, more exactly the FPGA chip. So I'm gonna create probably what I should do is do I even need this right now? Yeah, I don't. Oh yeah, actually I do. Git open DVI, and I'll have to copy. I have to copy two things. I'll have to copy constraints, and I'll have to copy pins CST. I'll definitely need clock. I'll definitely need yeah, clock and reset, and I'll definitely need everything that is related to DVI. Okay. So first of all, let's start with FPGA. FPGA. If we have a quartus, we should make something like yosys. Makes sense. Makes sense. Okay, so I'm gonna go into yosys and let's put everything that is board specific to this directory. Yeah, and we'll have to rename run shell to the to a separate thing that is specific to the tool chain. Okay, so let's copy pins and let's copy constraints, and probably we can just copy the. Oh no, we can't. We're gonna create the synthesis script from scratch, but for now I'm just gonna copy pins and constraints to the git on FPGA What's next? Yeah, yosys. Okay, so everything that is needed would be there. I don't think I need anything else, so I'm just gonna close this, and probably I'm gonna... I still need two LEDs, so I'm just gonna copy the LEDs. Yeah, probably here I'm gonna open pins, and I'm gonna add some LEDs here. What are the names? Maybe I should specify that it's LEDs inverted. Yeah, so I'm just gonna do LEDs. Or do I have I specified it in my zero over top? Actually, I haven't, because it's not inverted, right? Yeah, so I have to add LEDs inverted. Next thing is oh, actually reset is not the same as keys. So why do I have 3 keys? I don't know, but let's actually check. Let's actually check. So we have 3 keys here, and where do they go? I can just check for keys. So all keys are inverted, blah blah blah. Key 1 this, key 1 key 0 this, and okay, so we have a separate game reset. Makes sense. So yeah, we indeed need 3 keys. So I'm just gonna provide with 3 keys. Do I have a... Oh, I have only 1 key. Interesting. So I'll have to actually look up board to see what the... It's so nice that it's actually just written on the silk screen. So if my main reset is D10, I can say that game reset would be D7. Okay, so I can say that and all of these are inverted, right? So oh, it has key D3. Yeah, okay. So I have 2 keys already, but I'm just gonna copy more, and I'm gonna say that key inverted keys, right? Because here I have keys. Yeah, I'm gonna say keys inverted. And this is gonna be 0, this is gonna be 1, this is gonna be 2. The 0 is T3, the next one is gonna be T2, and the next one is D7. So T2, D7. And so I'll have to copy this to the my actual CST file that I use here. Okay, so I have specified clock, I have specified reset, I have specified keys, I have specified LEDs, and I have specified my HDMI data. Maybe I should explicitly say that it is for DVI. Is this how you write comments here? Yes, I'm unsure, but well, let's try this. Let's try just DVI, and this is self-explanatory. Okay, so we are done with pin connections. We have CLK, we have reset, we have everything from this list. Yep. And now let's see if we'll have to make some adjustments here. So yeah, we invert the LEDs, we invert the keys, we invert, yeah, basically we invert everything. Yeah, and I guess I'll have to specify that it's we have so here let's say that keys in I, right? So keys in I and LEDs in O is the correct. Yeah, LEDs in O is the correct stuff. LEDs in O. And here I'm gonna say that LEDs info is inverted LEDs, and LEDs comes from game top. This goes to game top, and RC goes there as well. Okay, cool. So we, and actually there's a typo. This is how you spell invert. So we've inverted all board signals, right? We specified the automatic reset after the start of the board. What else do we need? I think basically the last thing that we need to do is to actually implement the interface, display interface, and instantiate our DVI driver. But first of all, let's make a 10-minute break. So yeah, see ya in 10 minutes. Alright, so we are back. And now it's time to finish what we've started, right? Okay, so first of all, let's wrap around the instantiation of the VGA interface. Hello, SLBSH. Hi, how you doing? Am I quiet? Is it gonna be better now? Yeah, so let's go to the game top, and let's find, actually now let's go to the display. Right. So let's go to the display, and okay. Actually, yeah, it's gonna be a bit complicated because I was kind of sure that it is alright, but yeah, let's see. Advanced, so 1 second. Properties. Wait, why is everything default? Oh, I was sure that it's gonna be wait, filters. Oh, okay, yeah. So I've increased the gain by 4, so it should be better now, right? Yeah, and oh wait, yeah, somehow it just messed up. Let me increase the gain, like here. It's still low. Whoa. Actually, I think I have to go to the power control, and yeah, output devices. So yeah, inputs. Yeah, let's add it here. Yeah, and let's add it like here. Yeah, I think this is now, this should be good now, right? I think like here. Okay, nice. So yeah, basically what I'm doing here, as you can see, as I'm trying to port my game of Pong to the different board. So it was previously on the Intel board, and right here, oh my fuck, everything just dropped. Shit, give me a second. Yeah, whatever, gonna connect it later. So let me unplug it, and I'm just gonna show you what I'm doing. Yeah, so I have this Chinese board that has a HDMI output. So basically what I'm doing is I am converting the old project of mine that I did like last year You can see it here. And previously it was using the Intel board with the VGA output. And I am converting it to the new Chinese board with the HDMI output. So basically, yeah, what I'm doing today is basically I'm changing the source code of this game, so it would work on a different board. Yeah, VGA is a classic, but it's just a much simpler interface, and I've played around with it a little bit, and I'm just bored, and I'm ready to move on to the HDMI/DVI because it's gonna be much more interesting. Yeah, so basically, what I'm doing here is where I'm in game display. I have an instance of VGA, and right now let's try to. We have a right now we have a configuration for each board, and it has a display type parameter. So basically, we can just say display type, and if display type is 0, we're gonna use VGA. Otherwise, we're gonna use HDMI. So if, yeah, 0 is VGA, so we're gonna move it here. All right. And here I'm gonna instantiate the new DVI module. And let's look up what DVI module interface looks like. It is called DVI top, and it is configured with the packages as well, so I don't have to specify any parameters. Don't need spaces here, and let's connect the oh yeah, and I'll have to pass different clocks from the top. Yeah, maybe I can make serial clock the part of the DVI interface, so I won't have to do it separately. But for now, wait. Yeah, pixel clock is the regular clock, so I'm just gonna say that pixel clock I is gonna be just clock. What about, yeah, reset I is just reset. Is it here? Yeah, it is. RGB inputs. Wait, do we need RGB inputs to this module? Huh. Give me a second. Here I only have positions, and what about the actual colors? It has to be... It has to go somewhere, right? Oh, so the colors are actually generated separately. And in this module... Oh, do I need colors for the driver? Yeah, I do. So I have to pass colors here. And if I pass colors here, I don't actually have to pass it with to the output. Okay, this one do. Timer CLI you're using is kind of fun. Oh, it's just I don't even remember. Probably. Wait a second, maybe we can find it. It is called timer bin on Arch Linux, so probably you can find it. Timer bin Arch. Yeah, here it is. Yeah, so I'm using this thing. I found it like so long ago, and basically I forgot that it exists before like 10 minutes ago. All right, so let's get back to the DVI. We have clock, we have reset, so let's go back to board. I mean DVI top. What is the interface? Yeah, I'll have to provide the colors next, so I'm gonna say red eye. I'm gonna leave it blank for now. Green eye and blue eye. And I would get coordinates from the driver. So XO and YO. And I want to wrap the actual differential signals from the DVI to the separate interface. But before this, probably I should instantiate it like explicitly, and then later I would be able to create the interface and connect it together between modules. So it would be or maybe I can even change it later to the proper interface, but for now I just don't want to bother. Best viewers on steamboo.com. Yeah. How do I ban? I forgot how to click on things. Oh, yeah, here we go. Ban. Let's go. All right, so for now I'm just gonna keep the signals as is. So we have positive data. We have the same but negative, and we'll have TMDS CLK. Yeah, positive and negative clock as well. Yeah, so this basically is the interface for the DVI driver. Let's align everything properly. Yeah, so let's connect some stuff. Previously it was our VGA RGB. Why is it called W? Oh, wire. Okay, and VGA RGB is getting generated in the in this combinational logic, and then it's used in then it's basically becomes a register here. And why would I need a register? I just need a register to pass it to the output. Okay, but now I don't actually need an output, so I'm just gonna comment it for now. And yeah, I don't need this always block as well anymore. So all I need to do is I need to pass VGA RGB W. This is actually a very bad name, especially because previously I had 1 bit per color channel, but now I have 8 because I'm using DVI. So it would be better to like rewrite all of this. What is auto mod? No way, best URL, let's go. Held a message for a reason. Allow will post it to chat. Allow. I don't know what's happening. I'm not really familiar with Twitch. I'm just vibing on my own kinda. Alright, whatever. So previously I had a, or maybe I can just expand this this signal. So yeah, and VGA RGB is a bad name for parameter and comes from word package as well. Oh damn it. I just made it so, you know, not really portable. It just kills me. I'll have to play around it, but I don't know. I'm gonna see how to change it in a bit, but for now, maybe I can just change it to color width. Yeah, so let's drop the VGA part. Don't need this. Oh, and I can't rename because this LSP doesn't work. Okay, so I'll have to go through all instances of VGA RGB and rename it to RGBW. And it's gonna, yeah, Okay, so RGBW is here, and in this board configuration, I'm gonna say that it is actually 24. Yep, okay. So now we figure out how to make the proper size of the color, and what I'm gonna do next. And yeah, and we have separate board packages now, so I don't even have a generic board package. So how do I even configure this? Probably I should just pass it to, yeah, and I won't use VGA package as well. So probably I should create a like generic display package, and then based on the board I have to choose if I'm gonna use the DVI related parameters or VGA related parameters. Yikes. Seems like more work than I initially thought. I'm gonna have to add more tea. All right. So what I want to do now is, yeah, first of all, I'll have to separate the packages somehow. But yeah, let's finish with the instantiation of this stuff regardless. Probably it would be a better idea to separate the channels and then concatenate them later. Yeah, so what I want to do is maybe I should make a separate parameter and call it color width. Yeah, probably what I want to do first is to figure out how to make it work on one board and well, on a new board, and later I'm just gonna clean up because I don't want to deal with this now, so I'm just gonna say color W is gonna be color width, and it's gonna be 8 for each channel. And so here what I'm gonna do is I'm gonna say import primer 20k, which is the name of my board package, and I'm gonna import color W. Yeah, so color W is imported. And so after we've got it, let's create some signals. So I want to have logic color W -1 red, and green, and also blue. Alright, so I have 3 colors, and I can connect these 3 colors to the DVI module. So we have red, we have green, and we have also blue. Good. Then we'll have to, the easiest part would be yeah, we have VGA X pos and VGA Y pos. I'm gonna rename them later. For now, let's pretend that it's not VGA. So we'll have VGA X, we'll have VGA Y. Yeah, and these signals would be passed as a interface, but I can still create like, probably I should create a wrapper for them here. Yeah, so basically I'm gonna instantiate the appropriate module in this generate block, and what I'm gonna do also is I'm gonna create the modules to and connect it to the interface in this generate. I think it's gonna be appropriate, so let's go with logic 2.0. So we'll have 3 wait, yeah, we have 3 channels, which is serialized already. So we'll have logic 2.0 TMDS data P, same for N, and logic TMDS clock P and logic TMDS clock N. Right, so we have everything that we need, and we can connect it to the module. So TMDS data P, TMDS data N, TMDS clock P, TMDS clock N. Alright, so everything is connected. Well, not really connected, but at least connected to this instance. Which means that I can go ahead and do yeah, I'll have to clean up. I'll have to actually connect the appropriate signals, color signals to the generation logic. Found some gems recently that kind of stuff you into. I don't know, it's been so random recently. I just listen to whatever. It can be absolutely random. So from very aggressive 90s stuff to like songs for 14-year-old girls. So it's like very random. Basically, depends on my mood. But right now my mood is to create the not to create, but to port my game. This is what I am craving right now, is to go and finish this project, because I've been stuck with the DVI driver for so long, and it turns out it's not actually the code fault. My code is fine, but there's there was a bug in the tool chain that I've been using, and it took me like 3 months of debugging at night after work to figure it out. Well, I figured it out like sooner, but I've been trying to actually locate the issue so I can report it to the upstream to the tool, but I couldn't locate it because there's a big there's a lot of code, a lot of stuff that is going on for the DVI to work, and if you try to like create a minimal reproducible example, you have to cut stuff out. But if you cut something out of DVI, basically nothing works, right? And I've been trying to synthesize small sub modules, but all of them on their own work, but together we don't. And today I gave up. I found a workaround for that problem, and yeah, I'm just using vendor primitive instead of my own RTL pure generic solution. And yeah, I just decided that okay, I'm just gonna use that what works and move on to the actual fun part. So the fun part is to finally finish the pong game. What kind of mood would you have to be in to listen to 14-year-old girl music? I don't know. Sometimes you like sometimes you're going outside to touch some grass, you know, and the sun is shining, everything feels nice, and you're like you want to be the person who's like very happy with stuff. Yeah, and basically you want to listen to something very light, very that doesn't have any deep meaning, that yeah, so you basically put on your headphones and you turn your brain off and you listen to whatever. Anyway, DVI is here, and I forgot to actually give a name to the instance, so I'm just gonna call it idvi top. So pixel clock is here. Maybe it would be even better to create. No, it won't be. Yeah, so I have to provide a separate clock, because you actually need two clocks to work with DVI. You need one clock to the first clock is the pixel clock. So every clock cycle you generate the new value of your pixel. Yeah, so basically every clock cycle of the pixel clock, the DVI drivers move the coordinates of the pixel you change the color of. And the second clock is your serialization clock, because each color in DVI has 8 bits, but each channel in your actual HDMI cable has only 1 bit. Well, it has a differential signal, and so basically 2, but it's still. So basically what you want to do is you have 8 bits that you're sending in serial, so 1 by 1. And in order to do this, you need a clock that is much higher than your pixel clock, so you would be able to send multiple bits during one clock cycle of the slowest clock. Yeah, but unfortunately I won't be able to generate it here, because this code should be vendor agnostic, and the primitive that actually can create a clock is dependent on your vendor. Yeah, so I have to actually do it in a wrapper, and here I'll just send it. So yeah, basically for the DVI, how the interface would look like is that I'll have to send inside my module the serial clock, and I'll get to the outside board logic. I'll get data. So basically I'll get 3 channels of data, and 1 channel of serialized clock. Well, not serialized clock, yeah, we can call it pixel clock, but it's gonna be a differential signal also. Yeah, so basically this is how the interface would look like. Yeah, it will take a while, but we'll get there. Okay, so when display type is 1, we generate this, and when display type is 0, we have this. Yeah, and I'm gonna keep, I think I'll have to keep, oh, wait. Yeah, all right, so I'll have to remove the after removing the VGA, I'll have to generate it inside this block, so that I wouldn't lose my color when I use VGA. Okay, I'm gonna handle it later. Yeah, and VGA. So yeah, so basically we are detecting vsync, and when vsync is detected, we say that the new frame has arrived. Okay, we can generate it with DVI as well. It's not a big deal. For now, I want to figure out what to do with the generation, because here we have only 1 signal. But yeah, wait a second. Actually, what I'm using on this Pong demo is I have only black and white. Like, I'm not even using 3 channels, let alone 24 bits for color. Should I create the proper signal? Like, should I create the proper how would I say, the full depth of color or no. Yeah, it probably would be cool to have something like changing, but to have like a rainbow something on the screen, like you have a paddle in the pawn and it changes the color based on like position or something. Probably it would be cool, but yeah, that's pretty cool. Something I want to try out. So probably what I can do is I can change the generation of this color to the, yeah, I have to do a full true output. Okay, so let's say that I think red, like generating red, green, and blue is a nice way to handle it, but I'm not sure actually. Give me a second to think. Yeah, I think we can use the separate discrete signals, and after that we're gonna move on to the we can actually we can always make it like we can always cut bits from it to create the simpler VGA signal, right? So yep, I'm gonna do it now. By the way, SLBSH, like what's your experience with FPGA? Like probably if you're on my stream, you're something you're someone who is familiar with like Verilog, FPGA and stuff, right? Because otherwise these words would make no sense for someone who's not familiar with it, and it's probably wouldn't be interesting to watch. Alright, so here I'm gonna instantiate red. I'm gonna say that red is 0, and I'm gonna say that blue and green is also here. Yeah, so we have red, green, and blue. Red, green, and blue here. I'm gonna comment out VGA for now. So we have red, green, and blue. But I actually have to go here and like score is in the background, so our sprites overwrite it. If on score RGB. And what is the score RGB even? Okay, so yeah, it comes from score. Don't care about it now, but what I'm gonna do is actually I'm gonna do something very smart. I'm gonna say that this is red, green, blue, and I'm gonna assign score RGB to it. And for now, yeah, this would do for now. And if on sprite, I'm gonna color it with the sprite RGB. Yeah, I'm gonna do the same thing. So I'm gonna say that red, green, blue is, so yeah, so red, green, blue is sprite RGB and red, green, blue, sprite RGB and probably there would be a bit misalignment here, so it would be a good idea to cast this cast the bit width to the appropriate channel. Maybe like, yeah, so sprite RGB is dependent or on RGB width and RGB width. Okay, so yeah, no sprite yeah, so no sprite casting is needed here, it's gonna be the same width on its own. Yeah, and here, like display static separator. Yeah, all right. So static separator is actually very easy. We're just gonna copy this. Well, first of all, I have to align it correctly. Yeah, so after alignment, let's just copy it here. Well, let's assign ones to everything. So basically, if we have a separator, that means that we're gonna have a wide separator. I need to actually align it properly. Like, wait, why is it misaligned? Is it supposed to be like this? Why do I have green? Yeah. So I've messed somewhere here. Actually I didn't, but yeah, I have a full here. This makes sense, I guess. Yeah. I've started from microcontrollers as well. Actually, how many people get into FPGAs or start from the... well, personally, I started from Arduinos. And actually, I haven't got much further. Like, I've tried STM32, but I've never done something like complicated with it. Yeah, and I just went straight to the FPGA. Yeah. Alright, so if you don't know Verilog, it must be quite bizarre to watch this stream because you have like a lot of Verilog in front of you and probably, well, it looks like normal programming language. Verilog specifically looks like a lot of C. But the thing is that in Verilog we describe the actual hardware and actual electric circuit, like in actual circuit, all of the stuff happens simultaneously. And this is a very hard concept to understand, especially from people with programming background, because programmer used to doing stuff step by step, because your CPU can only execute one instruction at a time, given one CPU core, of course. Yeah, and basically it's kind of hard to write Verilog after like C, because you have to like get the idea of everything happening in parallel, and this is for synthesis. And basically we run Verilog in two modes. First is like you pass all the source code to the program that is called synthesizer, and you actually get the hardware circuit on the output. But most of the time we are actually doing simulation. So we are compiling the Verilog and running it on our like normal hardware on our CPU, so we can actually look inside what's happening. Because if you have a faulty code and you just synthesize it, like your circuit doesn't work, but you won't understand where to look because it's just a black box. You can't like write a print or run GDB and look what's inside. And so basically, if your black box isn't working, you're kind of doomed. So the first step is not to synthesize your design, but to actually simulate it, because in simulation you can actually look inside what is happening on every wire, if it's gonna make sense. Yeah, syntax is horrible. Yeah, but what is even more horrible than the syntax is that the actual standard is very bad. Like, it's very vague, and basically every tool is like doing its own thing. Like no tool is actually follows the standard, and so we have like some pieces of the standard that has been ratified in 2005, and to this day no tool actually implements what's in the standard, and you see it everywhere. Ever heard of Spade? Yeah, and so actually, I'm on the there's a digital design Discord server, and there's a guy who created it. So um, can't say I know him personally, but we've talked before. I am well aware of that language, but um, I'm not. I'm not yet professional. Yeah, I know Franz Carmen, but I'm not using his language though. But I use like I use Surfer. This is like the waveform viewer that he created, and this is very good. I actually like this. I actually like this tool a lot. Yeah, yeah, now I understand. Now I understand. Like one time I even got to his stream. His streams quite interesting stuff. Yeah, but the problem is that Verilog is basically industry standard. So if you want to get a job, you have to know Verilog in like 99% of the time. And I still think that Spade is very cool. I haven't looked into it yet because I've set myself a goal to get through 5 years of Verilog before switching to alternative HDLs. And the idea behind this decision was to learn the actual digital design first before learning languages, because I think the most important is the hardware what you do, not the language that you describe it in, if it makes sense. I don't want to be like in programming the person who like learns Python, then jumps to JavaScript, and jumps to C, then heard that Rust is cool, so he tries Rust. So he basically spends like 90% of the time just learning different syntax, but not actually learning how to program. Yeah, and I want to avoid this. I want to actually learn how to design stuff, and when I'm proficient in designing stuff, I'll learn like better ways to like describe it in text, because Verilog sucks. I hate Verilog. But like it's not an excuse. It doesn't matter. Like at this point, yeah, it's gonna be much nicer to use a language that actually just works without like 10,000 foot guns along the way. But for now, I just want to focus in on creating stuff, even if my language is shit. Well, people still use C. Even though in C there are a lot of problems that are solved in modern languages, but people still use C. So I think it really doesn't matter. You learn bad patterns that make it more difficult. Can you provide an example of a bad pattern, which is like specific to Verilog? In the meantime, I will continue with my Verilog journey. Yeah, so I have like 3 signals here, 3 signals here. Yeah, so basically I've provided all these signals to my DVI driver. I have the position, I have the TMDS signals. I will actually have to explicitly share the vsync, or maybe I can. Let's actually take a look at the DVI top itself, because probably it is already solved. Yeah, so visible range. Yeah, so I need visible range for something, right? Yeah, well, I can just say that VGA visible range is 1 here. So I'm just gonna say assign VGA visible range 1. Because for DVI it doesn't matter. In DVI it doesn't matter, so I'm just gonna say that it is 1. And how would I solve the new frame problem? Because for this I need vsync. Probably I can just generate it inside my DVI top and pass it. Yeah, probably this is the way to do this. Or maybe do I have another way to make it work? I can probably just use coordinates. Yeah, but for debugging purposes, I'm just gonna keep it the same as here. So yeah, basically I'm just trying to create something that works. It's gonna be pretty ugly, but after this I'm gonna clean up. Well, probably I'm not actually sure. I think if you know stuff on a low level, this is always beneficial. So I'm not sure. Like for example, my first programming language was Java, and in Java you have a very convenient way to track the array size. There was something like .length or something. I don't even remember. I haven't touched Java in years. But anyway, when I started programming in C, the first thing I learned is like you have to actually create the variable and track the array size on your own. And it seems stupid, but does it really matter that much though? Like you have to do something that is baked in other languages, but at the end of the day, it just really doesn't matter on the big scale, because on the big scale you're solving in case of programming, a computer science problem, and you have a certain approach in your head, and in the language all you have is just syntactic sugar, because you can use every like Turing complete language to do anything. So does it really matter? Because yeah, maybe you'll have to type more stuff, maybe you'll have to track stuff that you won't need otherwise in other languages, but at the end of the day it's the same. Like, and even if I'm gonna switch HDL right now, like I'm gonna create the same circuits. Like the DVI protocol won't be different, the signals won't be different, the registers won't be different, and yeah, it would be slightly more annoying, but I would just spend time learning different language. I'll spend quite a bit of time to do this, and right now I want to spend the same amount of time to actually learn how to design things. Yeah, so this was basically my approach, and yeah, after 5 years I'm gonna ditch Verilog for sure. I'm not gonna do anything in this language. Well, actually on the bigger scale I think that Python is like a syntactic sugar over assembly, but if we are talking about HDLs, like the true HDLs, all you do is you describe the behavior of a circuit during one clock cycle. This is basically all you do. If you're talking about HLS, which stands for high level synthesis, you're actually describing very vaguely what you want to achieve, and then you let the program figure out what hardware to generate for this. So you are not controlling the clock latency, you're not controlling how the registers and combinational logic is going to be distributed. But if we are talking about HDL, like, yeah, it's just the behavior we circle during one clock cycle. This is basically it. And it would be much more convenient to do it in chisel or spade or spinal HDL, but in the end it's gonna be the same. And at this point, the boilerplate that I have in Verilog, yeah, basically I just created snippets so I don't have to worry about it. Yeah, it's more code, but underlying principles is absolutely the same. Yeah, and also if you want to be employed, well, you don't have a choice, unfortunately. You have to know Verilog. Because, well, you might know only chisel if you are going to, if you're looking for a job in Sci5, they use chisel. But if you're an intern in Sci5, you still have to know Verilog. We're gonna train you on Verilog, and then they're gonna transition you to chisel. And so basically, I think 99% of materials on alternative HDLs assume that you know Verilog. Like when I was learning CocoaDB, this is like a verification framework for in Python. Like there's just Python code, but the manual and the book for CocoaDB still assumes that you know SystemVerilog, that you know how to how verification works in general. So yeah, I think it's the best way is to learn the industry standard way and then later to transition to something else, because unfortunately something else is just less used, so you'll have much less resources to learn. Well, I'm doing it as a job already. My full-time job is to write Verilog. So yeah, I am pretty much interested in I'm pretty much interested into being employed, because being unemployed is not fun. Anyway, so we've created red, green, blue signals, and right now let's address the new frame generation part. So basically I have vsync here, which is created by DVI sync module. And do I need to do anything? Maybe I can just where's vsync r? Yeah, so vsync r is here. It is going to be encoded, and after it is encoded, it is passed to differential serializer and differential signals. Yep. So all I can do, like differential signals is are fully combinational. Won't have to worry about the delay there. And serializers are not, but I don't think it matters because vsync is actually the output. All right. Or yeah, it is encoded. All right, so it is encoded, and after this it goes to where? Yeah, XO. Yeah, so XO is on part with hsync vsync, so yeah. Wait, and it just goes as an output. So probably I don't need a registered signal. I need a regular hsync signal. Actually vsync. So let's copy this. And yeah, let's copy this and let's say that we need to go to the DVI top. In IDVI top, and in IDVI top I need hsync signal. Yeah, I get it. Well, programming as a hobby is very interesting as well, but I don't know, I always just wanted to do technical stuff. So basically, I'm doing my hobby all day and even get money for it, so why not? It's been so fun, I don't even consider it as a job, but I'm getting paid to write Verilog. And at first it was like, yeah, Verilog, I'm not really don't really like this language, but after like a year of experience, I understood that it doesn't really matter. Like, the language doesn't matter. All that matters is your skill and your ability to design stuff. Well, it depends on what kind of job you do, because I'd imagine I would be very unsatisfied if I would do like basic boilerplate website front end JavaScript all day. Yeah, it would be devastating. But if it's something really interesting that just makes your brain click, then it's pretty fun. Like, I'm not doing, I can't even remember doing something at work that I dislike. Probably I enjoy every part of it. Well, maybe. Yeah, what I dislike is sometimes you have a task and you accomplish the task according to the constraints that were given to you, and later it turns out that these criteria was wrong and you have to redo everything. This is annoying, yeah, but yeah, whatever. Doesn't trigger me that much. Yeah, sometimes it's annoying, but most of the time, yeah, whatever. Still fun designing things. Okay, so we have, yeah, and I need vsync instead of hsync here. And now it's time to create an interface, I guess, because we've basically done everything that had to be done. Let's go to the primer board top, and I need to instantiate the PLL module to create a separate clock. We're gonna call it serial clock. Right, logic serial clock is here, and I'm just gonna copy paste PLL from my existing code. Not from here, but from, okay, don't need this anymore. I'm gonna go here, words top, and here we have our PLL module. Probably should be somewhere here. Let's align it properly. Sounds good. Sounds good. Yeah, CLK goes in. The serial clock goes out. And PLL lock. Do we need PLL lock for anything? Oh yeah, we do. Because yeah, I'll have to generate pixel clock from oh, no way. I'll have to use, yeah, all my timing constraints would fail because I can't use 50 megahertz clock for the logic because I have to use 25. Doesn't matter, I'm gonna figure it out later. Okay, if I'm gonna use a separate clock, what I wanna do, yeah, I need this primitive as well. So I'm just gonna copy paste this. Yeah, and I pretty much need PLL log for this, so let's add it as a signal. Logic PLL log. PLL log is here. And I need pixel clock div2 and pixel clock. Need more clocks, certainly. Pixel clock and pixel clock div2. Right. I guess we got everything. And I'm gonna provide pixel clock to the game top. It's the main clock. And what about this? Yeah, I'll have to create an interface, but do I want to start with an interface? Maybe I'm just gonna, yeah, maybe I should just throw stuff together, and after I confirm that it works, I'm gonna change it to a proper way. Yeah, so I'm gonna create junk at first, and after it, I'm gonna just clean up everything. I just want to create something that works real quickly. I don't mind if it's gonna be bad at first. Yeah, thanks for coming by. See ya. Speaking of which, I guess I'm gonna pour more tea, and I'll have to brew more tea later. Gonna brew more tea later. This is gonna be interesting. So yeah, okay. Let's for a second just forget about this. We'll have to let's just go to GameTop. And let's create some new signals. Like the output would be the same. I'm gonna command this stuff. Output is the same, and I'll have to input serial clock. Input logic serial clock. Input logic serial clock. This seems fun. This seems fine. Good. Good. So serial clock is here. Input logic serial clock. output logic this, output logic this. Seems good to me. What I'll have to do next is I'll have to pass it here, so we'll have to, oh my, I'll have to go to the game display. I'm gonna comment this stuff out for now. And basically I'll copy paste this stuff because it's gonna be the same. Input logic serial, blah blah blah. And from this we'll get serial clock, we'll get this. Yeah, no longer need this. At least for now it's gonna be fine. Primer 20 keyboard package, doesn't matter. Okay, so we found game top. In game top we have this. And in game display we have this. Okay, so because now game top has all the necessary signals, so we can go to the primer 20 keyboard top, and here we can have a, and here we can just correct this instance. So we're gonna say, okay, no more VGA. What we're gonna do instead, we're gonna create serial clock. Serial clock. Yeah, I'm gonna change all the signal name later. Okay. CMDS data P, CMDS data P, CMDS data N, CMDS data N, TMDS CLKP, TMDS CLKP, TMDS or CLKN, TMDS CLKN. Looks good to me. Looks good to me. Looks good to me. Right. I'm gonna align it real quick, so it's gonna be nice. I'll have to make this alignment on both sides. Control V. Right. Yeah, okay. Shift I. Good. And on this side as well. Actually, like this. All right. So what I wanna do now is, oh my god. Okay, so I have RPLL here. Right, so I have RPL here, I have CLK deep here, and I have game top here. Yeah, okay, so I've provided all the necessary DVI signals to the game top. Let's go to the game top and do the same with the game display. let's go to the game display. Let's see that the interface is correct. It is. So I'm just gonna serial clock, because it's here, right? Basically, I can just maybe copy paste it from primer. Yeah, primer bar top. I can copy paste it here. Looks good. Looks good for me for now. Don't want to deal with it anymore for now. Okay, so it is on game display. Let's go to the game display and see what we have here. In game display, all the DVI logic is connected, and yeah, what about DVI top though? In DVI top we have to provide serial clock, and I haven't yet. So I'm gonna write serial clock I. Well, not I, just this. Okay. So we are providing serial clock, and yep. So basically, everything should be working now, if I'm not mistaken. And I very much might be. Should I go ahead and use slang? Yeah, I probably am. Yikes, I just deleted my my slang just deleted my slang script. But whatever. Deleted my slang script, unfortunately. But nothing really serious though. Okay, so I have something that has a possibility of working. I'm gonna start slowly building this stuff up, but first of all, I have to write a script, right? Yep, I have to write this a proper script. Where am I? I'm in yosys. Right, so I'm gonna maybe each script should be in no. It should be here. So I'm just gonna say touch primer 20k uses. Maybe I should just call it synth primer 20k. Well, looks good. And I think it's time to make a break and brew some tea. Be right back. 10 min. Timer 10 min. Let's go. Alright, so we are back. So let's get back into the interesting stuff. Yeah, basically we'll have to create a script. So let's get into it. First of all, what we'll have to do is oh, this is gonna be interesting. We can just source it, right? Source assess cut suite environments. That what I'm gonna do is I'm gonna call yosys-slang p. I'm gonna say read slang, and then I'll have to describe the right sequence. So first of all, let's source. Second, let's slang like here, and then we're gonna help read slang. What do we need from here? From here we need libraries, inherit macros, and single units. So we say single unit, and libraries inherit macros. Inherit macro definition from the primary source files. Yeah, libraries inherit macros. Yeah. This is good. This is good enough. Maybe I should just keep it here. Yeah. Next thing that we'll have to do, what we'll have to do here is we can start with the include directory, and include directory is rtl/include. Why do I have rtl include? Yeah, so it is rtl include, and now I can actually go ahead and read all files. I can probably just say this, and rtl dvi, this would probably work. I'm not sure, but we're gonna try. I think we have a very highest chance of this working. Okay, so we've read all this. After reading, all that's left to do is to say synth govin top primer 20k board top, maybe whatever. Now let's make a separate primer, and JSON is gonna be design JSON. Yeah, so basically we've read all the files with Slang frontend. Oh, and I'm gonna have to create the black box. I'm gonna have to create a black box directory. Yeah, so I'll have to specify RTL black boxes everything. Then while I still remember, let's actually go and do that. So we'll have to go to the pong FPGA RTL. Let's create a black boxes directory, and now let's go back to the OpenDVI project. Let's go to the, oh, we don't have black boxes here. Oh, and I deleted every single instant that does. Interesting. Okay, so I've used PLL, clockdiff, and this. Yeah, and actually this. Okay, so it won't be that hard actually. So we'll have to go to the pong FPGA black boxes. We'll have to go into, yeah, here, and let's start with the actually what I want to start with is probably I should go to the COSS cut switch. I can go to the share yosys govin, and let's start with cells.map. RPLL would be probably here. Never mind, it is not here. Maybe cells extra here. RPLL. Still no RPLL. Let's search for RPLL. It is here. Yeah, so basically I'll have to copy this. Should I make a separate file for all black boxes, or for each black box, or I can just make a single file I think. But yeah, I'm gonna write separate just for the convenience. Okay, so this is the RPLL black box. CLK div2 would be the next black box. Let's search for CLK div2. Very interesting actually. But okay. This is CLK div2. From RPLL, let's copy the black box attributes, and I have to specify this explicitly. So I'm just gonna go like here. Gonna specify this, and I'm gonna specify this like here, and I wanna have a parameter in the end, just like the RPLL module. So yeah, module CLK div2, this input output parameter. We have one, so I can hear you. You can reply to me in chat. I will really appreciate it. Is this your passion? Yep. But sorry, bro. I can't type in chat all the time. I have to type code. Okay, so let's continue with what I'm doing. Basically CLK div2, and the next module that I'll have to copy would be CLK div, right? CLK div, and we need CLK div from GV to A. So basically, yeah, we need this model. So let's go and touch it. CLK div SV, and yeah, gonna be like this, gonna be like this. Input, output, and parameters in the end. Gonna be this, and from RPLL we'll have to copy the gonna copy the black box attribute as well. Then just I'll have to copy all the signals here. Nice. Okay, so I've got CLK reset, collab CLK out. So basically, yeah, all the ports are specified, and this is good enough. Since all ports are specified, we can go straight ahead to the next step of writing a script to synthesize this thing. Okay, so I'm done with yosys. What I'm gonna do next is I need to invoke next PNR, right? Next PNR, actually him by actual, and I can look up the exact command from here. So I'm just gonna copy this real quick. Yeah, I'm gonna just copy it here. Yeah, probably I can just do this, just so it would make more sense. Maybe I can actually yeah, probably I just should create a new line for every pass. This way it will look much nicer. Yeah, so this looks much nicer now. This looks much nicer. Nice. So this is the way to go. This is the way to go. Design placed. Okay. This is the correct info. CST, and I should also specify SDC. And where do I have my SDC for this? I have constraints SDC here. I have constraints here, and I have constraints here, and I have CST here. Yeah. So first of all, what I have to do is I have to specify the SDC. I think it is literally SDC constraints SDC, right? Constraints SDC. Yeah, seems correct, but let's double check. Let's run an xpnr himbachel and look what we have for SDC. For SDC we have basically a SDC file. This seems right. Where are you from? I'm from Russia. Cheers. Cheers from Russia. How about you? How are you doing? What's up? All right. So we have the right information about our place and route. So what's gonna be next? Next thing is to create the bitstream file. So let's instantiate govnpack. Let's run govnpack, and yeah, you can actually just copy paste this, because yeah, you don't have to fiddle with it, you just use this all the time. Yeah, you can basically use this, and after using this, all we have to do is to use open FPGA loader to upload the bitstream to the board. Not much to do here. We're gonna just run this as well. Yeah, so I have govnpack here to create a bitstream, and I can upload it to the board with this. So I think we have a script. Let's see if it even runs, because yeah, I have to, yeah, probably it's gonna be a bad idea, a good idea to run bin bash here. So nchmod plus x this. Okay, so we have an executable script. Let's try to run it. Okay, we have many issues. We have many front-end parsing issues. Let's see what it's complaining about. I'm from the UK. Nice to meet you. Nice to meet you too. Well, I have an offer, may I share it? Yeah, go ahead. You seem like a scammer, not gonna lie. Because most of the time, people who write stuff like this is a scam. But we'll see. Not gonna judge right now. CMDS has no connection. Huh, this is interesting. Oh, I understand why. I'm gonna fix this later, but now let's address the missing packages. Now let's address the missing packages. Okay, so basically, oh yeah, and I have to, this is actually a very smart idea to make it fail if it's like if the command fails, then the whole process should be shut down. Okay, and I think I can grab the script from here. The basic idea is if not this, then let's say that exit 1. And we'll have to repeat it from repeat it here. Then p exit 1. Same goes here. It's actually very nice that they're like they are outputting the status. Yeah, this is probably common, but still pretty cool. Okay, so we have everything. So if something fails along the pipeline, we're gonna stop. Probably I can just use like a pipeline fail, but whatever. Okay, so this seems like it is somewhat complete. So let's run this one more time. Yeah, we have one more issues and now it's stopped. Do you need some nice artwork for a channel in good price? Then ban me, lol. Not gonna ban you. Seems like a legit offer. Do you need to worry about price? Also, I'll give you reasonables and also write me in Discord, using and chats, and so you can show my recent artwork. No, bro, I'm not a scammer. Tell me you're just kidding, so I can show you my work. I appreciate the offer very much, but currently, as you might see, I have 2 viewers and 2 followers. Basically, and this is like my first time streaming in a month or so. So basically, in my current state, I'm unfortunately not really interested in like prettifying my channel. Like I am not invested in the looks of it. I'm just interested in the like the actual programming content inside of it. But nonetheless, I appreciate the offer. With the set, let's continue with the programming stuff. So it can't find the package. It can't find the package. This is unfortunate, but let's just it should find include. Maybe I should write it like here, like this, and it's gonna find it. Seems like it didn't help. No such file. This is interesting. Running, executing Slang frontend, top level design, single units, libraries, inherit macros. I'm pretty sure this is how you do this. I'm pretty sure this is how you do this. Just zero, please. Well, even if I would be interested in you know updating some artwork, as I stated earlier, I'm from Russia, and as I live in Russia currently, I have no way of exchanging any transaction with you, because Russia is sanctioned to shit. So even if I wanted to, unfortunately, I can't even pay you. Unfortunately, there's no way of me paying you at the moment because there's no Swift connections running. Simply put, my credit card doesn't work outside of Russia. Anyway, so for some reason the board package is not found. The board package is not found. What could this mean? What could this mean? That the credit credit, well, the package is not found. Oh, the board package wouldn't be found. This is all right. Yeah, I have to change all the instances of board package, right? This is actually not an issue. Okay, so there's all board package. Yeah, so I should go and change every instance of board package. I think this is the wrong way to do stuff. I should probably just do what? I should probably keep board package and configure it accordingly to my board. Yeah. This seems like actually things that I had to do. Okay, so fine. I'm gonna use board package everywhere. So let's go ahead then, and in the pong FPGA, yeah, RTL, black boxes, all right, DVI, all right. What about board package? What about board package? It includes. This is the board package number 1, and this is the board package number 2. Okay, so we have 2 board packages, but yeah, let's just very interesting. Yeah, it says UVA board package, and this is just I think I've lost the previous information about this. Okay, should I just create an if-def or something? Yeah, probably I should. Yep. Okay. So what I want to do is I'll say, okay, just give me a nice old board package. Wait, can I do this? Yeah, nice. So this is just a generic board package, and I'm gonna create an if-def here. If-def primer 20k else, I think it was else if, no, it was else, no, it was else if, and if def, and if, yeah, so if def is the correct, and else if is the correct word, holy shit. Okay, else if 0, 1, and this was the primer configuration, and this is 0, 1 configuration. And probably I should add like else, and I can, maybe I should do initial error. What can I say? Initial error. Run board configuration. Either this or this should be defined. Initial error on board configuration, either primer 20k or 0 should be defined. Right, so this seems like something okay. So this seems nice. If def primer 20k, else 0 else initial on board configuration primer. Okay, so I think I've given enough hints. I've given enough hints. I've given enough hints. Yeah, so basically this is alright. This is I want to approach this stuff. What I'll have to do next is to I have to get rid of the OVA package. Like primer 20k package, this is the only package you need. We do have variable error at end package. Like, what is exactly doesn't... Is it this? So it doesn't like error for some reason. I'm gonna fix this. Or okay. So let's like later. Is there a man later? Okay, define. So dash D primer 20k. Okay. So I'm gonna go to the later. Oh, it's not here. On FPGA verilator.f. Oh, it's not getting used because it's like not conf. No, yeah, probably I should just say D primer 20k. Maybe I should move it here. And after it, I'm gonna remove let's actually go ahead and check config and vim and init luam verilator. Okay, so we have to actually go to the plugins, kickstart plugins, lint verilator.conf. Yeah, so we need do I need verilator.conf on this account? I can just keep verilator.def. Yeah, so cd config and vim, cd config and vim, Lua custom plugins, so custom plugins lint, and here I'm just gonna sneaky go and delete this. Okay, so we've deleted this, and now when we ignoring swap file. Okay, but we don't have any issues anymore. Variable. Oh. Relator file name does not match. Okay, but the variable is complaining. The variable is complaining about macros. I really don't want to lose variable in this. It's gonna be tragic. But I don't have a choice. This is like the best way to do it so far. Either I'm losing variable on this, or I'm just not having the correct configuration. So let's say that, oh, okay, variable, I don't care about you. Yeah, so let's go ahead and just we're gonna delete 0 1, and we're gonna board package SV, and we're gonna rename it like this. So the board package SV, and Verilator is happy with the name. Verilator is happy with the name. That means that I'm happy as well. Okay, so what about primer? We have this, we have this, we have this. Seems good enough for me. It looks good to me, not gonna lie. Oh, and I forgot about very crucial black box, and it has to be something TLV, something like TLVDS buff. Like it's not even here. Okay, whatever. So let's go ahead and fix something. Like do this here. Like res primer 20k board package. So this is board top. Yeah. Okay, so basically what I want to do here is I want to go here and delete this. Cannot find include file. Oh, because it's this include file, and if it couldn't still find the board package, it's not my problem. Use of undeclared identifier. Oh my god. Okay, whatever. No member names key W in package board package. Is this actually true? This is actually true, because I forgot to say. Like, do I even need this? Yeah, probably I do. Okay, whatever. So I'm gonna say it's the same stuff everywhere. So I think I have to say like D primer 20k, right? What if I run this? Yeah. No member VGA RGB. But hey, we have less errors. And no connection. Clip, clock out, CLK. Clock output has no connection. RPLL instance. Yeah, probably I can explicitly connect whatever. Use of undeclared identifier. Okay. Probably I should make it work in Verilator, and it's gonna be much easier that way. No member named VGA RGB in package board package. Sprite display wants this information. Okay. Let's call it VGA RGB for now, because who cares? Certainly I don't. Certainly I don't care at all. Okay, ZOVA board SVH, not file, no such file. It is found in ZVA ZOVA board top. Okay, let's fix ZOVA real quick while we are at it. So ZOVA should be happy. ZOVA actually is happy. Game top, serial clock has no connection. Oh, this is ZOVA warnings, and I don't care about ZOVA. I should probably... Oh, and this is ZOVA as well. This is unlucky, because I don't care about ZOVA being unhappy. Probably what I should do right now is I should make pretty explicitly clear that ZOVA is not welcome. How can I approach this? I can say something like, I have to explicitly say it. Okay. Damn it. I really don't want to. This is such a nice way to do stuff. Huh. How can I do this differently? Is there anything that can be of help? Give me some time to look up. Okay, so probably I can source this. I can say yosys-slang, and I can say help read slang. And I need something that I can ignore, right? I mean, ignore. Define a rule to ignore vendor command. Parameters, ignore directive. Until EOL, ignore unknown modules. Ignore time and initial assertions, whatever. Not interested in this. It won't be that bad. I have to only specify them once. So still a hustle though. Definitely still a hustle. Maybe there's a way to make it like better. There should be. There should be a way to make it better. But I don't see it yet, unfortunately. Maybe I can go to to the ZOVA top and wrap it in if the ZOVA and all of a sudden it makes sense now. And I don't care. Yeah, probably gonna keep it like this. Because who cares? Would my script be happy now? Certainly is more happy. Use of undeclared identifier RGBW in game display. Let's go to the game display and see what's happening there. Game display. RGBW. What's the difference between RGBW and VGA RGBW? Not much. Yeah, like RGBW is supposed to be the for now I can just duplicate. Who's gonna care? Certainly not me. Use of RGB. Wait, what? I have it, bro. Chill. Oh, okay. So I have to say, board package RGBW. And supposedly that would make my little stuff happy. Certainly more happy. Use of undeclared display type. Because I haven't passed display type, have I? I was gonna change it quick. From word package, we're gonna transfer display type. Use of undeclared identifier TVI top. Huh. Not like this. DVI top is not. Display type is 1. There should be DVI top. Okay, let's try this. Could not resolve hierarchical path name. Okay, so IDVI top was a better choice. But for some reason it fails. Use of undeclared identifier. VGA vsync out. Oh, okay. So I forget to change it here to IDVI top vsync. So now I have two problems at once. That IDVI top doesn't exist. Undeclared identifier. I'm pretty sure I have to be able to. Yeah, I'm pretty sure I have to be able to use the instance name to refer to the inner hierarchical signals, but for some reason I'm not able to do so. And this is pretty disappointing, I would say, but I don't know what to do with it. I'll have to look into this. Yikes. Already streaming for 3 hours. It's been tough. It's been tough, but for some reason we are still going. Generate where? Yes, this code is a little bit outdated, but yeah, I guess I'm just gonna work on it slowly. But first of all, I want to make it work, and then I'm gonna make it better. We'll have to make it better. Word package, VG, sprite package, clock resets, serial clock, TMDS, new frame display red, green, blue, blah 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 blah. Not very interesting at all. Probably, as we are using. No, if def is a bad idea. if that is a bad idea. Why is it a bad idea? Yikes. Why is it a bad idea? Won't be able to do stuff. Yeah, maybe I should consider just making a macro. But for now I'm just gonna chill. I have to figure out why can't it understand what I want to do. Because even Verilator does. Actually, let's run this code in Verilator. Oh, lint only Verilator F. Well, unexpected what? Include instead of include. Unsupported Verilog config preserve word not implemented. What's happening? What's happening? I'm pretty sure that this is correct. Why are you so unhappy with what I'm doing? This is bizarre. Preserved Verilog word. Are you serious? Like what? RTL, include RTL. Like what? Syntax error. Unexpected. Maybe I should just source the right version. Maybe it will get better. Relator. Wall. It seems fine. Oh my god, I forgot the fab. Okay, so it makes sense now. John unnamed. Misindent. Misleading. Implicit. Signal definition not found. Implicit error. Oh, yeah. Oh, it should be. I can't find definition of scope variable IDVI top. Damn, seriously? Even Verilator can't find it. This is tragic. And what is even more tragic is that it can't find word package SVH for some reason. Like, bro, are you alright? Why can't you find it? It's literally in the... Are you sure we are on the same page with you, bro, darling? Because I can't find everything. RTL. Maybe if I'm gonna Yeah, okay. So there was a weird issue and now it's fixed. Duplicate declaration, blah blah blah. What? Excuse me? Primer board top. Primer 20 keyboard top. Oh, okay. That's not an issue. Okay, so currently everything works. And if we go to the game display, yeah, we'll have an actual errors. Signal definition not found. And we don't care about this. We can even simplify this. Can't find definition ID IDVI top. Bro, are you for real? Or I can call it DV agent. I can call this VG agent. Oh, this has got me. This stuff got me. Got me twice, basically. I should have had to comment this out. Because I'm not using VGA RGB anywhere. Yeah, so this has to be commented out. But what about DVI top, though? Can I just, you know, create nothing like this? Nothing. Okay, this seems like a logic piece of code. And if I do nothing, dotted reference to instance that refers to missing module interface DVI top. Can find definition of vsync in dotted variable method nothing vsync. Okay, so this actually works. This is interesting. What about package though? Package, board package. I said board package. So what's so wrong about it? Display type. Display type should be 1. It should make this visible. And for some reason it just doesn't work. Okay, fuck it. You know what? Don't care. Just gonna do something very silly right here. Just gonna create logic vsync. Let's go to the DVI top. Let's say output logic vsync. Nice. So I can just say here vsync. Gotcha. Get you working. Okay, so vsync is working, and here I can just get rid of this. I can just say vsync. What Verilator thinks about it? Missing modules as expected. Okay, so everything is expected. Maybe what we can do is we can even pass the black boxes, because why not? Maybe it's gonna find. Can I find module? Oh, okay. I have to actually say why here. I'm gonna move it here. RTL black boxes. Whoa. Very later lit only. Cannot find file missing module. What about YRTL? Very later, let's look at the dash Y to search for module. This seems correct for me. Mod missing. Why are you missing, bro? RTL black boxes. Is it the legit RTL black boxes? Yeah, this should work. But it doesn't. I don't care what you think. I'm just gonna clkdiff clkdiff2 dvi rpll. Mod missing. What do you mean mod missing? I've explicitly said where to look at. Okay, don't care about this error. If you don't want to find my modules, so be it. Not very happy with it, but it's life. Not every module can be found. Okay, so if I synthesize this right now, oh, it should miss stuff because I forget I have to. Oh shit. I should also primer. Let's go to the primer and let's de-govern. And it says that TLDS buff is not found, and this is a legit issue. I'm gonna fix it right now. Let's go to the black boxes and let's create TLVDS buff, and we can copy paste this from where. We can go to OSS Katsuit, we can go to share yosys-slang, and we can search for TLVDS buff. Found it, yikes. Okay, so here we are, and we're gonna go to the RPLL to get the attribute correctly. And we don't care about the behavior, we only care about the instance of this stuff. Yeah. TLVDS buff is done. TLVDS buff is done. and it should automatically pick this stuff. And yeah, we are finally running synthesis. So it's time to connect the fail to open CST file. Because the name is actually pins CST and it is in yosys. Yeah. So it's pins and it is in yosys, and it is in yosys as well. Okay, so let's try one more time. Okay, so the place and route is working, so it's time to connect the hardware to test our little pong game. Pixel clock was routed using global resources. Yay! This is very, very promising. I'll hope to get some image. If we get something out of it, it's gonna be very, very cool, and I'm gonna go to rest. We'll have to fix my game for tomorrow's stream because apparently it's fucking awful. Yeah, and I still pretty much ill a little bit. Well, not a little bit, I'm just fully ill, I'd say. Yeah, but this game is pretty horrible, but yeah, I had to check the audio and design PNR no such file. Oh my god. So we have a pass for pixel clock. Oh, nice frequency, by the way. And pass for serial as well. Clock has no interior paths. Slack, whatever. Slack. Warning, info program finished normally. Design PNR not found. Okay. Let's open this up and see. Oh, it's called placed. Let's call it placed as well. This is unfortunate. This is just very unfortunate sequence of events. We'll have to wait for a little bit for it to synthesize properly. And after we wait a little bit, everything's either gonna work or not, and if it won't, I will be pretty upset. Yeah, it will be disappointing. It will be very, very disappointing. New frame is routed using segments. Interesting. routed using segments. So there are some pieces of the logic which are routed using segments for some reason. This is interesting. I'll have to look into this. But I'm gonna spend a fair amount of time cleaning this up because obviously it requires a lot of work. Obviously it requires a lot of work. But all I want to do is just to make an initial baseline on which I can improve the quality of my code, the quality of the structure. Right now I'm just, you know, messing around. Even if it doesn't like, even if it's not perfect, I think I've done a good enough job. At least I've done a good enough job. And would we have something on the screen? Seems like yes. Holy fucking shit. It works. It have worked the first time. If it's actually gonna be playable, I'm gonna piss my pants. So let's try. No, the buttons doesn't work. And I pressed something stupid. So this is the reset. Oh, so this is the buttons to actually do this. Oh my god, it works. It is indeed working. Yikes, I'm losing. Oh, I've managed to win. Yikes, I won. And I'm not just talking about the game. I won the actual coding session, so to speak. Oh, excuse me, my mic is here. Okay, so actually I want to upload it on YouTube later. Maybe if it's not like 100% fucked up audio wise, I'm gonna upload it. Okay, so I want to have a, give me a second. I'll try to have a nice angle on this stuff. Damn, it's gonna be hard. It's gonna be really, really hard, but maybe like here? Question mark? Give me a second, I'm gonna, oh shit. Not again. This display has fallen today. I don't wanna repeat this. Don't wanna continue this trend of dropping my display for no reason. Okay, so basically. Okay, so let's see if I can make it, if I can manage make it seem nice. Nice. Oh, give me a second, I'm gonna stretch it like this. Okay, so this, ladies and gentlemen, is the board. It is Tank Primer 20K, and if you press a button on this thing, I don't know how to show it properly. Okay, so yeah, well, maybe like this. Okay, so if you press a button, you have to restart, so it's like the third button. No, not the third. Maybe this one? Not this one. This one, fourth one. Yeah. So you restart the game, and then you have two buttons to play it. Oh, and LEDs blink. Okay, so let's try to beat this guy. This is actually hard. I think I'm losing. Well, hopefully he's stupid too. So I'll have a fair competition. As you can see, the speed is changing and the angle is changing randomly every time. Let's play one more game. So we have to play. We have to press the fourth button. 1, 2, 3, 4. This one. And the game starts again. And the game starts again. And we play it. Damn it. It's been so hard. Honestly, I'm very impressed how it turned out to work like the first time we've done it. This is actually insane. I'm very impressed and I like how it turned out. Yeah, so basically a huge shout out to yosys-slang for making this possible, because normal users can't handle this, but as you can see, yosys-slang handled it without any issues. So yosys-slang, huge props to you. Yeah, and what else to say? Yeah, I'm very impressed how it turned out. So I guess I'm gonna clean up everything tomorrow to make it perfect. I mean, regarding code. And after this, it's just gonna be insanely good. But I like this so much already. This is so satisfying to just play the thing that you've just made. Oh my god. This is like unimaginable. Yeah, this is good. This is good stuff. Honestly, so impressed how it turned out. Yeah, I printed this thing like previously one time, and it worked relatively easily that time as well, but right now I'm just testing the capabilities of yosys-slang, and it impresses me. I'm very impressed how it turned out. Like the code of this game is like 1 year old during the time that I just started learning Verilog, so it's pretty rough. I know how to do some things better, and I think this is what I'm gonna do later today. I mean, tomorrow. I'm gonna clean up some stuff. I'm gonna clean up the um, yeah, I'm gonna clean up the mess that I've done while trying to port DVI. And so after I clean up all the mess, I'm gonna improve the old code, because there's some things that can be done better. For example, this score, the digits of the score, as you see here, actually they are not scaled. So for each pixel you have a memory element, and as you can imagine, that's a lot. So yeah, I'm gonna change it later today. Tomorrow, not today. I'm done for today, because yeah, this is just very impressive. Yeah, debugging this thing would be a nightmare without proper test bench, but I think I did a pretty good job. I did a pretty good job. So I guess, yeah, this is it. Thanks for watching. If it would be okay to listen, I'm gonna upload it I'm gonna upload this to YouTube, and if the audio would absolutely suck, then yeah, unfortunately, GG. But yeah, I'll try my best to make something watchable out of it. And if you're watching this on YouTube, then yeah, I've succeeded. So yeah, I'm really tired. I'm gonna continue tomorrow with this thing. So the plan for tomorrow is to make this basically perfect in every aspect. Make it portable, make it use less resources, and um, yeah, basically nothing more to it. Yeah, maybe we can play around with it a little bit. Like the idea that I had is like not make the whole game plain white, but actually change the color accordingly to the according to the the coordinates. I think it's gonna be pretty cool to have some sort of a rainbow, but yeah, I have some ideas. Maybe we'll take a look at it tomorrow. Okay, so that's all for now. Bye bye.